The discriminant and the graph of quadratic functions. Determine the number of x-intercepts each graph will have. Then make a sketch of each graph. The equations we've been given are quadratic functions. We can see that from the x squared. And each of them are in what we call standard form, which looks like y equals ax squared plus bx plus c. Now, in order to determine the number of x-intercepts, let's recall a few things. First of all, the graph of a quadratic function will be a parabola. And if we want to figure out the x-intercepts of the parabola, we want to figure out where the graph crosses the x-axis. And all points on the x-axis will be something, 0. In other words, we will want to figure out what values of x make the output 0. Also recall that the way we solve an equation in the form ax squared plus bx plus c equals 0 is by using the quadratic formula. And if ax squared plus bx plus c equals 0, and a is not 0, then the quadratic formula says that x will be equal to the opposite of b plus or minus the square root of b squared minus 4ac divided by 2a. Now, the inside of this square root is what we call the discriminant. This b squared minus 4ac is called the discriminant. The discriminant helps us to determine how many solutions ax squared plus bx plus c equals 0 will have. If the discriminant is positive, then there will be 2 solutions to this equation. If the discriminant is negative, then the equation ax squared plus bx plus c equals 0 will be if the discriminant is negative, there will be no solutions to this equation. And if the discriminant is exactly equal to 0, this equation will have exactly 1 solution. So, if we want to determine how many x-intercepts there are, we want to determine how many solutions there are to ax squared plus bx plus c equals 0. And in order to do that, we can use the discriminant. So, let's go back to our first equation. Let's determine what the discriminant would be. The discriminant would be negative 2 squared minus 4 times 1 times negative 3, which would be 4 plus 12, or 16. And since 16 is positive, there will be exactly 2 x-intercepts. Now let's go ahead and see if we can make a sketch of this graph. Now we know that this is a parabola. We even know, since the coefficient of x squared is positive, that the parabola will open up. And we know that this parabola has 2 x-intercepts. Let's figure out where those x-intercepts are. So the equation again is y equals x squared minus 2x minus 3. If we want to determine the x-intercepts, we want to know what values of x make the y equal to 0. In order to solve this equation, we could use the quadratic formula, as we discussed below, but it would actually be easier to factor. If this factors, then these 2 terms would have to be x, and these 2 terms would have to multiply to give us minus 3. Since 3 is a prime number, these 2 factors have to be 1 and 3. And if we make the 3 negative and the 1 positive, then the outside terms would multiply to give us minus 3x, and the inside terms would multiply to give us 1x, and minus 3x plus 1x would be minus 2x. And of course 1 times minus 3 is minus 3. Now that we've succeeded in factoring this equation, we know that either x plus 1 equals 0, or x minus 3 equals 0, which means that x equals negative 1 or x equals 3. And these two x values are the x-intercepts to our function, which means if we sketch the graph, then when x equals -1, the y will be 0. And when x equals 3, the y will also be 0. Now, let's see if we can find the y-intercept of this graph. So we have the equation y equals x squared minus 2x minus 3. If we want to find the y-intercept, we want to figure out what's the value of y when the x is 0. If x is 0, well, the y would have to be -3, because the terms with the x's would disappear. So that means that the y-intercept is 0, -3, which should be right here. And so our parabola would look something like this. Take a moment, pause the video, and see if you can determine how many x-intercepts this equation would have, and then see if you can make a sketch. So, let's first determine what the discriminant would equal. The discriminant would be -20 squared minus 4 times -2 times -50. -20 squared is 400. -4 times -2 times -50 would be 400. And since we have a negative times a negative times a negative, that would be a minus 400. And 400 minus 400 equals 0. That means that there must be exactly one x-intercept. So, let's see if we can make a sketch of the graph. So, we know that there's exactly what's one x-intercept. Let's see if we can determine what that x-intercept is. So again, we're going to try to determine what the value of x equals to make the y 0. So, if we have 0 equals -2x squared minus 20x minus 50, in order to factor this, the first thing I will do is factor a -2 out of all three of these terms. -2 times x squared is minus 2x squared. -2 times a positive 10x will equal minus 20x. And minus 2 times a positive 25 will give us minus 50. Now, let's see if we can factor this trinomial, x squared plus 10x plus 25. Well, both of these would have to equal x. These two numbers would have to multiply to give us 25. Let's try 5 and 5. Let's try both of these as plus. Let's just make sure that this multiplies to give us x squared plus 10x plus 25. X times x is x squared. We get a 5x from the outside terms and a 5x from the inside terms. 5x plus 5x would add up to 10x. And 5 times 5 is 25. So, we can see that since these two factors are the same, that means only x plus 5 can equal 0, which means x equals -5 is our one and only x-intercept. So, in order to sketch the graph, we know that the x-intercept is at -5. We should also know by looking at our equation, which is y equals -2x squared minus 20x minus 50, that the parabola will open downward. In order to get an accurate sketch, it would be nice to figure out what this y-intercept is. This y-intercept must have an x-coordinate of 0, since it's on the y-axis. So if we go back to this equation, when x is 0, y would be -50. So that means that the y-intercept is negative 50, and our graph would look something like this. Now try part C. Again, determine the number of x-intercepts, and then make a sketch of the graph. Now, first, to determine the number of x-intercepts, we will look at the discriminant, which would be negative 4 squared minus 4 times a half times 11. Negative 4 squared is 16. 4 times a half is 2, and 2 times 11 would be 22. So this would be minus 22. And 16 minus 22 would be negative 6, which is negative. Therefore, there are no x-intercepts. Well, that makes it perhaps more of a challenge to graph. So, in order to graph this, we know it doesn't cross the x-axis, and we know that the parabola opens up. So it must look something like this. But perhaps the vertex is somewhere to the left of the x-axis, or perhaps it's somewhere to the right of the x-axis. All we really know is that the y-intercept is 11. Now, if you know how to find the vertex of this parabola, you could do that by completing the square, or there are other methods for doing that. But you might consider just pulling out your graphing calculator and making a rough sketch of the graph. If you were to do that, the graph would look something like the following. By using my graphing calculator, I see that the vertex is to the right of the y-axis, and it does not cross the x-axis. So again, in order to determine the number of x-intercepts of a graph, determine what the discriminant is. If the discriminant is positive, there will be 2 x-intercepts. That's what happened in our first problem. If the discriminant is positive, there will be 2 x-intercepts. If the discriminant is exactly 0, there will be 1 x-intercept. And if the discriminant is negative, there will be no x-intercepts.